Hi there! If you have an IBM online coding assessment, you are at the right place. In this video, I would like to share my own experience with IBM online coding assessment that I did for two positions, one for AI and data engineer and another one for associate data engineer. Both assessments included two parts, one in SQL and another one in Python. Both assessments included the same identical SQL part, but different Python parts. In this video, I will cover all of them. If you pass the online coding assessment, you'll be invited to another online assessment where you'll be given 5 behavioral questions that you have to answer them in star schema. For each question, you will have 1 minute to think and prepare and 3 minutes to answer. In the end of this video, you will get all 5 questions that I had in my assessment. So let's get started. The database task is pretty simple. You have a products table and a request table, and you need to clearly identify the most popular advertising products. You want to make sure that only advertising products that are available should be included. In fact, these tables do not have a lot of columns. You can see that the products table has is available column, which if you filter for equals to 1, you will cover this part. So you're going to connect these two tables, filter for available products, and group them to count the total request per each product. I've researched similar Leetcode problems that you can practice on your own, or you can watch the videos of my solutions that I will put in the description of this video. Next task is the coding task. I solved it in Python. I think you can solve it in a different language, but it's recommended by IBM that you solve your tasks in the language that are used in the description of the position. You can read the whole task in my GitHub account. Short summary, you are simulating a live video player. To play the video smoothly, the player needs exactly one specific packet per second. In perfect order, you have at second 1, packet 1, at second 2, packet 2, and so on. You are given an array of packets and the arrival rate. Arrival rate 2 means you receive 2 packets per second. If a packet arrives early, you save it in a buffer to use later. If a packet arrives late or is completely missing when its second arrives, the video player crashes and freezes. For example, we have an array of different packets, and here we have 2 4s. These are the duplicates. A duplicate packet 4 is received and ignored. Your goal is to write a function that simulates this process second by second. We need to find the exact second the video player freezes because it doesn't have the packet it needs. So we need to return that second. And if the player receives everything on time and the video never freezes, we return -1. Let's move on to the solution. This solution passed all tests in the IBM console. The core trick here is to realize we are dealing with 2 different timelines: the time the server sends the data and the time the video player actually tries to play it. Our strategy here is to group the packets by the exact second they arrive and then simulate the video player ticking forward second by second. We create a default dictionary to group packet IDs by the exact second they arrive. We need the maximum packet ID to keep track of the highest packet number we receive. This tells our simulation how long the video is supposed to be. This part here fills out our dictionary with the packet IDs and their second they arrive. The formula we use here is once we iterate through all indexes, we divide index by the arrival rate and add 1. This gives us the exact second it arrives. So if the arrival rate is 2, indices 0 and 1 arrive at second 1. So at the first second we have the first and the second packets. Next we calculate the maximum arrival time and maximum simulation time. Here we add the arrival rate -1 to round up the ceiling division. If you have 9 packets at a rate of 2, the last packet arrives at second 5. The simulation has to cover the entire stream. So we take the maximum of our 2 timelines, the video length versus the download time, because the simulation must run up to either the highest packet ID or the maximum time frame of the stream. For buffered packets, we use a set. A set makes sure that the numbers are unique. And with the following for loop, we simulate playback second by second. The T here represents the current second. We fetch whatever packets the server just delivered to us during this current second. Then we check if packet is already in the buffer from a previous second. If packet is already in the buffer, the video plays successfully. If not buffered, it must be the very first arrival of this second. If the packet wasn't in the buffer and it wasn't the first packet to arrive from the network, the player is out of options. The video freezes. So we return that T to output the exact second the rebuffering occurred. If the for loop finishes completely without ever hitting that previous return T, it means the movie played perfectly from start to finish. So we return -1. These two were the tasks for an associate data engineer position, and if you want to practice similar tasks, these are the Leetcode problems which you can practice on your own. For an AI and data engineer position, there was a different coding task, which was about implementing an auto-scaling monitor strategy. You need to implement the function to process a sequential array of system utilization data points and determine the final number of running instances at the end of the monitoring cycle. Here are the scaling logic rules that you can implement through an if-elif statement, and you have two input parameters. You have the initial number of running instances as instances and an average utilization. It's an array of integers representing the average system utilization percentage. It's a simple Python solution, so you have two pointers. You start with a 0 pointer and the last pointer, which is the length of the input array, and you define the maximum allowed instances. The maximum allowed instances you have in the description. It's here. It should not exceed the absolute ceiling of 2 times 10 to the power of 8. This is a simple while loop. While first pointer is smaller than the last pointer, we take the number from our array and we check the rules. If the utilization is less than 25%, we reduce instances to ceiling instances divided by 2. And if utilization is greater than 60%, you double the instances. If an action was taken, you skip the next 10 seconds. In other case, you move to the next second. And in the end, you return the instances. And again, if you want to practice similar Leetcode problems, these are the numbers of Leetcode problems that you can find and practice on your own. If you pass the online coding assessment, you are invited to an online behavioral assessment. In this online behavioral assessment, you have 5 questions. You have 1 minute to prepare yourself and 3 minutes to talk about each specific question. You don't see the questions all at once, so you basically click on next. And in my case, these were the questions. So first you see the question, you have 1 minute to prepare and 3 minutes to talk. Then you have another minute for another question to prepare and again 3 minutes to talk.